Hello everyone, welcome back to this session on numerical integration. Today we are going to see a very special topic in numerical integration. Usually in numerical integration the limit is from -1 to 1 and you have a function which is a function of epsilon and you want to integrate it with respect to d epsilon. Some textbooks use the notation r instead of epsilon. All right, but what if the function, let us say that the limit is from 2 to 4 or maybe from 0 to 2, whatever be the limits, and you have a function, let us say you want to integrate a function of x squared plus 2x, and you want to integrate with respect to dx. Now, if you want to solve this problem by numerical integration, how do you do that? Because you have the values of w1, w2, epsilon 1, epsilon 2. You have evaluated those values only when the limit is between -1 to +1. And you have those values only for epsilon, when the function is in terms of epsilon. I have used the notation epsilon, so I'm saying epsilon. Of course, you may want to use the letter r instead of epsilon, completely at your discretion. Okay, in this case, we have the obligation to change the limit to -1 to +1. Okay, and you also have the obligation to change, to write x in terms of epsilon. If you can do that, then the problem is solved. So two things. First, you have to change the limit from -1 to +1. That is number one. Number two, you have the obligation to write x in terms of epsilon. Okay, so how do you write x in terms of epsilon? That is, let us say that x is a function of epsilon. And the simple function that I can assume is, I can assume a linear function, which means that x is going to vary in a linear fashion with respect to epsilon. If that is the case, then I can say x is equal to a0 plus a1 epsilon. So once I can evaluate the values of a0 and a1, I have got an expression for x in terms of epsilon, then my situation is solved, right? So let us see how we can find the values of a0 and a1. Very simple. You just have to apply the boundary conditions. So what are the boundary conditions? At x is equal to 2, right? At x is equal to 2, the value of, because here x is 2, the value of epsilon is -1, right? So in that case, it is a0. Of course, the value of epsilon is going to be -1. So I will put -a1. This is going to be my first equation. Now, let me apply the second boundary condition. The second boundary condition is at x is equal to 4, right? The value of epsilon is +1. So let me apply this particular boundary condition. So at x is equal to 4, the value of epsilon is +1. So it is going to be a0 plus a1. So this is going to be my second equation. Just I have to solve these two equations. Once I add these two equations, I get 6. Of course, a1 minus a1 plus a1, they cancel each other out, is equal to 2a0. This surrenders the value of a0 as 3. Okay, so once I know the value of a0, I can immediately substitute the value of a0 either in equation 1 or 2. I can get the value of a1. So I can just see a1 is equal to a0 minus 2, right? If you take this a1 is equal to a0 minus 2. So this a1 is equal to a0 is 3, 3 minus 2 is 1. So the value of a1 is 1. Now I can substitute the value of a0, a1 back in this. Let us say that this is the star equation. I will be getting x is equal to a0, which is 3, and a1 is 1, 3 plus epsilon. So I got the value of x now. I have got an expression for x in terms of epsilon. Now all I have to do is take this value of x and substitute it here. And I have got the limits evaluated, and I will be putting the limits between -1 to 1 because that is the boundary condition. Very simple. So let me do that. So it is going to be from -1 to +1. The value of x, it is going to be 3 plus epsilon, the whole square, plus 2 into the value of x is 3 plus epsilon. And very important, very, very important. Sometimes you may overlook this. See, you also have the obligation to write dx in terms of d epsilon. Please don't forget that. It's not always going to be as simple as dx is equal to d epsilon. No, it's not always going to be that way. For that, you have to differentiate this equation with respect to epsilon. So if you do that, the 3 just disappears, and if differentiation of epsilon with respect to epsilon is just 1. So this gives dx is equal to d epsilon. As I told you, not always dx is going to be equal to d epsilon. In this particular case, however, dx is just equal to d epsilon. So once you got the value of dx, you can just substitute it right here. So dx is equal to d epsilon, all right? So now I can just expand this. So let me do this in a step-by-step fashion. So integral over the limit minus 1 to plus 1. It is a plus b the whole square. It is going to be a squared plus b squared plus 2ab. And plus, let me bring this 2 inside. So it is going to be 6 plus 2 epsilon. And of course, I have to integrate this equation with respect to d epsilon. So on further simplification, I'll be getting integral over the limit minus 1 to plus 1. So it is going to be epsilon square plus 8 epsilon plus 15. Of course, I have to integrate this equation with respect to d epsilon. So that is the equation. So let me integrate this equation. So I'll be getting epsilon cube divided by 3 plus 8 epsilon square divided by 2. That will be equal to 4 epsilon square plus 15 epsilon over the limit minus 1 to plus 1. So upon the substitution of the upper limit, I will be getting 1 by 3 plus 4 plus 15. This is the upper limit. Minus, upon the substitution of the lower limit, I will be getting minus 1 by 3 plus 4, because minus 1 whole square, it's going to be plus 4 minus 15. So if I simplify this term, I will be getting 19.333. You can just check it through. And if I simplify this terms, I'll be getting 11.333. Of course, it's going to be plus sign. So if you just solve this, you'll be getting 30.666. That is the answer. Now, how do we know this answer is correct? So let us do this problem by the exact method, where the integral is from 2 to 4 and the function is x square plus 2x. Of course, you are going to integrate with respect to x. So if I just simplify this, I'll be getting, if I just integrate this, I will be getting x cubed by 3. Of course, plus 2 into x squared by 2. So the 2 just disappears over the limit 2 to 4. So let me substitute the upper limit. So it is going to be 4 cubed divided by 3 plus 4 square. So that is the upper limit. Minus, if I substitute the lower limit, it's going to be 2 cubed divided by 3 plus 2 square. And upon simplification, this term reduces to, 37.333. And upon simplification, these terms reduces to 6.666. Of course, there is a minus sign here. And if you just subtract these two terms, you will be getting 30.6666. You can just check it through at the privacy of your room. So that is the answer. And you can see that the two answers, they go hand in hand, shoulder to shoulder. Which means that the function, which is, let us say y, which is a function of x. And if you have this function, I'm just drawing a random curve, where the limit is from 2 to 4. And if you have to find the area here, right? Of course, that function is x squared plus 2x. This particular function y is equal to x squared plus 2x. It is the same as a function where you have got epsilon The limit is from -1 to +1, and you've got a function that just goes something like this. I'm just drawing a random curve, and it is like finding the area. This area and this area is just going to be the same. Of course, what is this function, right? Let me call this as eta. Of course, eta is equal to, in this case, eta is going to be equal to this particular term, this function, right? That is it, epsilon squared plus 8 epsilon plus 15. Epsilon square plus 8 epsilon plus 15. Of course, that is a function. That is the function eta, right? With respect, and you are just integrating with respect to d epsilon. So it tells us that each and every point on this curve should have a corresponding point here. And the area, these two shaded yellow areas, though I have not shaded in proportion, it should be just the same. That is another interpretation. So to summarize, any function, right, and any limits, between any limits, right, it need not always be -1 to 1. It can be from 6 to 15, whatever it is. And if you have an obligation to integrate that by numerical integration, where you always have to have the limit from -1 to +1, then you can follow this procedure. I have not solved this problem by numerical integration, but instead I have solved this problem by exact integration. You can solve this problem by numerical integration because we have already solved enough problems by numerical integration. So you can solve this problem, this exact problem, by numerical integration, and you can see that the value comes to 30.666. You can just check it through. So thank you all for your patience. Thank you so much.